When we're talking about thermodynamics, there is usually something that is energy. And remember that work is a transit energy, as heat was, and we have already explained heat in previous tutorials. But what happens, for instance, with work? Well, for instance, let's suppose that we have any given cylinder with a piston. And this piston, or this cylinder, has a certain pressure and a certain volume. Then all of a sudden an external work is provided. Let's suppose that this is going to be compressed, and then the pressure will change, the volume will change as well. For instance, this is going to be P times delta V. And of course there is a force which was being applied here, and there is a certain displacement. So the work states that if we state that the differential of work is going to be equal to the force in a dot product with a displacement, and we are actually stating that the force and the displacement goes toward the same direction, so this is going to be, for instance, force times dy, and force related with pressure is pressure times transverse area times dy. Now, area times dy is, for instance, the differential of volume. So the differential of work is going to be, for instance, pressure times the differential of volume. This is very important because this is how you get the thermodynamic work, or the moving boundary work. It is called a moving boundary work because the boundary of the system is moving. For instance, if the boundary was at the beginning this, then at the end the boundary has moved towards this. That's the reason why it's called a moving boundary work. And the thermodynamic work, or moving boundary work, the total work is going to be generated as the integral from volume 1 to volume 2 of P delta V. If volume 1 is larger than volume 2, then it has occurred something that is, for instance, a compression. And if we have a compression, then the work is going to be, for instance, negative. But if the volume 1 is less than volume 2, it means that it has happened an expansion. And a work on an expansion is a positive work, because the difference in volumes is going to be positive and pressure is always positive, so the work is positive in that case. And the other case when compression, because the volume is negative, the change in volume is negative and the pressure is always positive, then the work is going to be negative. Work is an integral. So for instance, if we have a graph of volume and pressure, and there is certain any given process happening, for instance, and it goes from volume 1 towards volume 2, well, if the process goes in that direction, then it's going to be positive. If the process goes towards that direction, then it's going to be negative. But the total work, for instance, is the area below the curve, right? Because this is an integral, so the integral is the area below the curve. So the work is what we called a path-dependent function, because it depends on the path. If the path is another, for instance, if we move to the same B1 and B2, but the path is different, then the work is going to be, for instance, different, right? So this is a path-dependent function.